Hello guys, in this video I will discuss about the next problem related with the DFS or BFS. For the practice purpose, in this video I will include one lead code problem, number of island. Okay, this is the problem number of island. You can solve this problem either BFS or DFS approach, but in this lecture I will discuss this solution using DFS. I am thinking that some problems uh, some problems are that this that means these problems or sub problems are mainly uh, or only solved by BFS, can't be solved using DFS. So that type of problem will be discussed using BFS. Okay, so in this video I am going to discuss this problem solution via DFS. Let's understand what is the problem. The statement is the problem was given an m cross n 2D binary grid which represent a map of 1 and 0. 1 denotes land, 0 denotes water. Return the number of island. And what is island? Island is surrounded by water and is formed by connecting adjacent land horizontally and vertically. Main point, horizontal and vertical only you connect lands. You may assume that four edges of the grid are all surrounded by water. This is also important. That means that means around the grid water is present. Okay, let's clearly understand this question using this example. Actually, yes, this is the example of the second example, and you have to return the number of island. Let's start from figure. Let's understand what is Iceland. This is the grid of 0 and 1s. Here island means, in this question one thing is given that you can take this also. Okay, here 2D grid, one denotes land. Okay, that means this is land, and 0 denotes water, that means this is water. And also Iceland, that means an island is surrounded by water and is formed by connected adjacent land. That means ho- that means you can connect adjacent land by horizontally or vertically, only horizontal vertical. And that means you connect this land and this land via, that means you connect this land horizontally, you connect this land vertically, you connect this land horizontally and this land vertically. So all these land forms one island. Okay, you cannot connect this land because this one and this one is of diagonally. Okay, in diagonal direction, so you cannot connect this land, because in this question we are able to connect only horizontally or vertically. Okay, so you can connect only horizontal, vertical, you cannot connect diagonally. So this land will be not included in this island. So this is one island, this is another island. Let's So this will be your one island, and this will be your another island. This one also can't be connected because this is the diagonal direction, but these two horizontally can be connected. So this will be the one another island. So the number of island present in this diagram or in this grid is 3. So for this type of grid the number of island is 3. Also, one more statement, you may assume that all the 4 edges of the grid are surrounded by water. That means if this is the grid, okay, then all the water, that means 0, all the this grid is surrounded by water. That means around the grid water is present. So you can say that this is Iceland because Iceland is surrounded by water. So from this direction water, and from this direction water, from this direction water. So this is Iceland, this is also Iceland, this is surrounded by water. This is the another end. It's the total number of islands. Okay, I think you have understand, okay, this question. Let's discuss the approach by use this problem can be solved. For understanding clearly, now I am going to draw one same same grid. Okay, number of row is 1 2 3 4 and column is 5. This problem is this problem can be simply solved via DFS. Until I am drawing this grid, you also try to think about what is the DFS approach for solving this problem. Okay, so let's discuss 1100 1 and 0 0 0 and 0. This is 1 1 and 0 0 0. This is 0 0, sorry, 1 1 and 0 1 0 0. 0 means water, 1 means land. Okay, let's forget this. So now, how how can you take an approach to solve this question? Let's understand. Actually, if 1 2 is vertex, then there will be one edge that will connect these two vertex. So solving this problem, can we imagine one imaginary edge present horizontal and vertically to connect this land? You can means you can imagine one virtual edge between one between horizontal and vertical. You can imagine. This is the main trick to solve this question. Okay, so let's first, so say that means we follow same DFS approach. So so for solving DFS approach, this is grid of m cross n, that means 4 into 5. So for same direction we have to make visited array, because we already in DFS approach one visited array present, and that visited array is of size number of vertex. As this is 2D matrix, so we have to so for all box, you have to make one visited array. This is visited array. Okay, this is visited array, 2D array, because in this problem 2D visited array will be used to solve this. You can treat one box as this is the 0 box, 1 box, 2 box, that means 0 vertex, 1 vertex, 2 vertex, 3 vertex. That means each box treated as a vertex, and so to connect these two land, we treat as imaginary horizontal edge. You can treat vertical imaginary edge. Okay, so let us start. that means we have to start from 1. We have to connect only land because Iceland is connection of land, so we have to start from that box of grid where value 1 is present. So we have to, means you will start from here. So you will start from here, make this visited, and similarly this is the same similar to the number of connected component of number of provinces. So make one count value which denote the number of island. Initially make count value is equal to 0 and number of times, and we will try to start new island formation from every box, because one box will maybe give one island, but this island may not give, this answer may not give total number of. So so follow same approach, we have to start or make, try to make DFS call or make new island formation. We have to start DFS call from every box. That means you should try to make DFS call for every box. Okay, so let's start from one. Here present one, so you can make call, make, put this visited value equals to 1, visited box value equals to 1. Initially count is 1, sorry, initially count is 0. So when first DFS call will be done, okay, so increase count value equals to 1. Now this is like node, then this vertex or node will try for the adjacent neighbor. Then what, then this will try for, it can travel only horizontal and vertical, so it can try for one horizontally and also for this box. So it will try for this. Okay, it will try for this. So check this box is unvisited. Yes, this is unvisited, so mark this visited. Okay, mark this visited, and also this count indicate that number of times this DFS call started. So here the the box from which DFS call will be a start, I will tick. Okay, I will tick. So we have ticked here, that means one DFS call is a start from here. Now this call for this child and make this visited. Now this child try for all its neighbor. Here it will try for 0, but 0 is water, so we cannot connect land. Only it will call for those one, it will call for their neighbor horizontal vertical which is land. Now it will try for this, and here present land, so this, and also this is unvisited, so make this visited, and now this will try for this one, but this one is visited, so this will try for this one, and this one is unvisited, so this can call for this one, and make this visited. Now this one try for all its neighbor, this one and for this one, but this one is already visited, this neighbor is already visited here. So that means here all call is done. One check for all its neighbor. Now its call will return from 1. Its call will be return. Okay, that means this call will be returned from 1. Now I'll try for its 1, that means already visited, this one try for its neighbor. Now this call will be returned. Okay, this returning showing that the df how a stack call or call is returned. Okay, so now that means from here you cannot make another visited or another, you cannot connect any other land. Okay, so now you 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 have tried for this, from this box to make DFS call. Okay, you have tried from this box to make DFS call. Now you will try, you you have you will try from this box. If you try from this box is one, that means land, but already visited. Okay, this is already visited, so you cannot start DFS call from here. Now you try from here. You will try only when this is land. You can try DFS call from this box only if if it will be one, but this value is 0, so you cannot start from this. Check for this. This is also water. You cannot start from water because you have to only connect land. You will try to make DFS call from this is 0, so you cannot call DFS call from here. Now you will try from here. This is 1. You you may try from this box, but now this is 1. Then again check, is it visible? Sorry, is it visited? Yes, this is already visited. That means you must have to check two things. Either it is that means it must be land and also must be unvisited, then only you will call for DFS call from that box. So you cannot call DFS. Now try from here. This is 1, maybe chance, but already visited, so you cannot start from here. Let's start from here. This is water, so you cannot start. This is also water, so you cannot start. This is water, so you cannot start. That means that means you have covered already that things. Okay, that means you have to cover these things. Okay, now you will try from here. This is water, so you cannot start. This is also water. This is land. Okay, this is land. There may be chance to start DFS call. This is land, and check value here. The already this is land and this is unvisited. Land and unvisited. So you can start call and make this visited. If you start DFS call, then you have to tick this tick showing that DFS call is started from here. And if you tick and DFS call start, you increase count value. Now count value is 2. Now you will try for all its neighbor, but horizontally and vertically there is no any land, so child call will not be done. And call, that means all call is done here. Okay, for this island. Now start from here. This is water, so you cannot now start DFS call for here. Now try to start DFS call from here. Now start DFS call from here like this. But this is water, here is water, so you cannot start. This is land. Okay, this may be chance to start DFS call. This is land. Now let's check for visited area. And also visited area is unvisited, that means value 0%. So you have to start, you must start from here. So make this visited and tick this tick showing that new Iceland is started from here. So if you are started, then make count value in +1. That means now count value is 3. This one will call for horizontally and vertical. So the horizontal one land is present, so this land call for this land. That means you may connect this. So now you only connect if this land is unvisited. So this is already unvisited, so make this visited and call for this. Now this is visited. Now this one try for all its neighbor horizontal and vertical. Now this land try for that, but here water outside grid cannot call. Now we try for this one neighbor, but this one is already visited, so it cannot call for this one. Okay, so now call will be returned, and this one already done its neighbor, so now DFS call will be ended, and here your count value is 3, and which is your correct answer. Okay, so this approach is similar to the similar problem, or this approach is similar to the number of provinces or number of connected component. Okay, so let's implement this approach to solving this problem. Now let's go. Okay, I will try to code this the same coding, follow the same approach that I have discussed in this lecture. First, make visited area of 2D of same dimension that the grid dimension. Okay, what is grid dimension? Let's name grid as area. Int m equals to number of row, area dot length and denote the number of columns. Array of 0 dot length. This is the row, this is the column. Now make visited array. Sorry, int 2D visited array. Okay, and size m cross n. Default by the default value of visited array will be 0 in Java. Okay, now another, what's the next will be try to make DFS call from every box, because in this problem every box will be treated as a vertex. So we try to start DFS call from every box. For that, make one for loop. So I is less than m I plus plus int j equals to 0, j is less than m, j plus plus. Now when when will you call when will you call you will call if and only if there will be land and will be unvisited, then only you can call for DFS call. Okay, so if array of ij value will be 1 or must be 1, this is the character array or int array, character array. Okay, so 1, and visited value of that ij must be 0. That means till now this node or this box will be visited. Okay, so sorry, will be unvisited, then only you can call for it. Okay, if this is the scenario, then make DFS call. Let's here make DFS call, and if make new DFS call, then try to count. This count indicates that one new island formation is started. We have started. Okay, so in DFS call, what we will pass one array that means this grid, and a starting point that means I comma j, starting a row column, and also visited. Now we have to make void DFS. Okay, this is 2D array int 2D array int row denotes the number, a starting row number, a starting column number, int visited. Now the first, what will the next, the first, if you start, then make this visited. Okay, make this visited, that means make this value 1, this ij value make 1, then make visited of here row and column will be 1, and now try for all its child. And what will be the child? You can try only adjacent land, that means adjacent horizontal and vertical, only adjacent. If you are at if you are at that point, if you are at that point, then you can call only for this box, or from this box, or for this box, or for this. That means you can only one box up down and one box left right. Okay, you can call only one box. Okay, so for this purpose one box left right. Okay, for one box, if you are at this I comma j, okay, then this will be I minus 1. Okay, this will be I minus 1 and j, this will be I plus 1 j, I plus 1 I plus 1 comma j, that this will be, sorry, I plus 1 comma j, I plus 1 comma j, this will be I j, I and j plus 1, this I j plus 1, j plus 1, this is I and j minus 1. Okay, j minus 1, that means this is I minus 1 j, I j plus 1, I plus 1 j, and I j minus 1. So you can, for this purpose, you can make one global array of one is row and one is column array, of size 4, of size 4. Okay, let's, how can we make one global array, global array, this make this row of size 4, row of, that means if this row, then try for this dimension first, then this, then you try for first this direction, then this direction, and you can, you can arrange according to you, but try from here and in fourth direction like this, you try from, if you are, you go towards that zero index showing that, that means you have to decrease row, that means minus 1, in this direction row will be increase decrease 0, that means row will be same, in this direction row will be increased by 1, in this direction row will be same. Okay, that means if you are up, then row will be minus 1, then 0, and plus 1, then 0, this will be row, then make one int column equals to, column equals to, if you go in this direction first, then column will be same, in this direction column will be increased by 1, in this direction, in this direction column will be same, but in this direction column will be decreased by 1. Okay, so column, first direction column will be same, and then column will be, column in right direction column will increase by 1 plus 1, and in next direction column be 0 and then minus 1. Okay, so now if you are at any node and make this feasible, then now next step is you have to make all 4 direction, that means you have to make all child, here child is 1 2 3, that means you can make 4 all adjacent and call for add adjacent call for all adjacent call. You have to make int I equals to 0, I is less than 4, that means we have to make 4 call, and int new row equals to row plus row 0, row 0. Okay, then int new column equals to, what is the value of new column, column plus column of I, what is the column, sorry, this column of I, row of I, this row or column indicating that if you make call in this direction, that means if you are at, if you go towards that first, this is a 0 1 2 3, if you go towards in this direction, this I will be minus 1 and j will be same, so this indicating that the first 0 value I will be minus 1 and j will be same, second indication that your I will be same, j will be increased by 1, here showing that I will be same, j will be increased by 1, so this is, for this purpose I have made this global row and column. Now next is, now you have to check, if you call to the child, then you only call that child value is 1, that means that should be land and unvisited, then only you can call for that child. If this array value of new row comma new column must be equals to 1. Okay, and also this must be visited, so new row new column must be visited, okay, equals to 0, must be visited, then only you can make dfs call, dfs, and dfs call for array new row new column comma visited. This is the simple straightforward dfs approach. And if we have to solve this problem, then we have to return the number of count initially make count equals to 0 and count equals to 0. Okay, I think this code should be run. Okay, dfs, sorry, this is showing that income table type char cannot be converted into int array. Char array cannot be converted into int array. Okay, sorry, this should be char array. Then array, yes, wrong, it's wrong. Array index out of bound. Oh, sorry. This array index out of bound showing that there may be chance that if you are at this value, and if you can call, if you call from the in four direction, then this call is violate call or maybe go out of the grid. So to protect to go out of the grid, you must have one. You must to write new row should be in a range and new column should be range. New row must be greater than equals to 0, and also new row must be less than equals to array dot length. Okay, and also column must follow same approach. New column should be greater than equals to 0, and new column is less than array 0 dot length. I think this code should be run. First make direct correct dimension call array dot length. Okay, to best case request, let's check for the all test case. Accepted. So this is the code for this problem. Okay, so now in next video I will analyze the time and space complexity of this problem, because if I will try to add time and space complexity analysis in this video, then this video may be bigger. Okay, so thank you. In next video I will discuss.